In this video, I'd like to quickly derive the double angle formulas for the sine and cosine using sum and difference angle formulas that we already know. So let's start with the sine of 2 theta. The sine of 2 theta I can just think of as the sine of theta plus theta. And this allows me to use the angle sum formula for the sine. That's going to be sine theta cosine theta plus cosine theta sine theta. And multiplication is commutative, so these two terms are in fact the same. We have 2 sine theta cosine theta. Cosine of 2 theta for the first formulation is essentially the same idea, right? We're going to take this double angle of 2 theta, write it as theta plus theta, and then apply the angle sum formula for the cosine, which is going to be cosine theta minus sine theta sine theta, right? And certainly this is cosine squared minus sine squared. Okay. The other two formulations for cosine of 2 theta just come from using the Pythagorean identity and substituting into this equation. Right, so we know cosine of 2 theta is cosine squared theta minus sine squared theta. Cosine squared theta is equal to 1 minus sine squared theta. Right? Because cosine squared plus sine squared of the same angle is equal to 1. And here we have 1 minus 2 sine squared theta once I drop the parentheses. The other formulation I'm going to substitute into sine squared using the Pythagorean identity. So I'm going to substitute in 1 minus cosine squared theta. And when I subtract these terms here, right, distribute the negative 1, so I have cosine squared theta minus 1 plus cosine squared theta, which gives me 2 cosine squared theta minus 1. So these double angle formulas we see really coming from the angle sum formulas